Hey guys, today we are going to discuss this problem. Its rating is still 1800. So as always, we are going to start with explaining the example here. So in the example, we are going to have an array. The first number is the nonce of the array, and the array is 1, 2, 3, 4, 5, right? And we are going to do these steps. So first, we are going to choose any numbers from the given array. So let's say we choose 4 and 5, right? So the array B is 4 and 5. And then we are going to calculate S for the array B. So we are going to apply AND operator to all of these numbers. So what we have here, S equals to 1, 0, 0, which is 4, right? And then we are going to find the biggest V, which satisfy this condition, 2 to the power of V divided by S. So in this case, 4 equals to 2 to the power of 2. So that the value 2 satisfy this condition, so that the biggest V is 2, right? And of all the B arrays, output the one has the biggest V. So we can choose different B arrays like 1, 2, like 1, 2, 3, etc. Right? Of all those B arrays, this array will have the biggest V, right? For example, let's try this array, right? We are going to calculate S first. So the S of um, 1 and 2 is um, is 0, right? And the biggest V for 0 is actually is none, right? Is minus 1 due to our problem says because we cannot find a V, right? So let's choose a better example here. If we choose 2 and 3, then the S for 2 and 3 is 2, right? So in this case, the V for S, S2 is 1 because 2 equals to 2 to the power of 1. So this guy, 1, is less than this guy, 2, right? So obviously we cannot choose this array. Instead, we need to choose this array. And we are going to output this array, right? This is the length of this array, and these are values of that array, right? So how do we solve this problem? Um, So first, let's transform this condition here. So let's say we have a S. How do we find the V for this S? So for example, if we have S equal to 6, what is V for 6? So um, I'll tell you the um, transformation here. So all we need to do is find the rightmost one in the binary. Um, and um, the V is the um, place of the rightmost one in the binary form. For example, in this case, the rightmost one is at the second place, right? So the V here is 2 minus 1, which equals to 1, right? Let's validate it. So 6 can be divided by 2 to the power of 1. So that's correct, right? 1 is the correct V for 6. Let's take another example. 10. If the S equals to 10, then the rightmost one is at the second place. So the V for it is 2 minus 1 equals to 1. So let's validate it. 10 can be divided by 2 to the power of 1. So that's correct. Let's take another example here, this guy. So the rightmost one is at the third place. So the V for this number is 3 minus 1, right? 2, which is 2 to the power of 2, which equals to 4. So 4 can be divided by 12, right? So 2 is the best V, right? Let's take yet another example, all right? This guy. So the rightmost one for 16 is 1, 2, 3, 4, 5, which means 5 minus 1 equals 4. So the V equals to 4. Let's validate. 2 to the power of 4 equals to 16. And the 16 can be divided by 16, obviously. So V equals to 4 is the correct answer. So that means in order to calculate a V, we only need to find the first we only need to find the rightmost one in the digital in the binary digital representation, right? And in order for the V as large as possible, we only need to make sure that the S we got has the leftmost first one, right? So we need the first one in the binary form as left as possible in the S, right? So with that being said, all we need to do is to find such a S, right? So we can iterate from the best S to the worst S. What is the best S here? So the best S is to have the first one as left as possible. So that the best S is like this, right? Um, so as we can see in the problem, we got uh, the upper limit like this. So the best S we are going to have is to have one here, and we got 30 uh, zeros after that, right? This is the best S we can have. And the worst S is like this, right? Just one, right? So that we can check from the best S to the worst S, and to if we find a array that can give us the uh, target S, we can break out of the loop and output that array, right? So I guess the rest of the problem is to check how to check if we can find such an array that satisfy this satisfy a specific S, right? So how can we do that? So let's say we have a S like this. And we want to find out that if we can construct an array from this array that have a S like this, right? So we are going to choose some numbers from the array, and we are going to do the AND operators for those numbers. So we can iterate from the first number, and let's see if we want to choose it. So obviously we don't want to choose 1 here, because if we choose 1 here, that means the final end result will be 0 at this position, right? So we can never have a end result like this, right? So we cannot choose 1 here. So can we choose 2? Same as before, 2 has a 0 at this place. So it contradicts the S here. So we cannot choose 2. So can we choose 3? No, it's 0 here. Can we choose 4? No, it's 0 here. Can we choose 5? No, we can it's 0 here. So that means this S is not applied to this array. We cannot choose some numbers from this array to have an end result like this, right? So that we can choose, we can try the next S, which is like this, right? So can we have a S like this? Let's try it. So um, as we did before, we choose from the first digit. Can we choose 1 here? Um, the answer is no, because the third digit of the this of 1 is 0, so it contradicts this number. So we cannot choose 1. Can we choose 2? No, the digit is 0. Can we choose 3? No, the digit is 0. Can we choose 4? Yes, we can choose 4 here because the digit here is 1. And can we choose 5? Yes, we can choose 5 because the digit here is 1, right? So that we find uh, 2 numbers here, and we calculate the end result of these two numbers, which is 100, and it equals to our target S. So in this case, we can output this array, right? Which is the final result here, right? That is how we check if a specific S can be calculated from the given array, right? So I guess that's it. Let's move on to the code. So first, we are going to read the given array. Then we are going to iterate from the best S to the worst S, right? The best S is 1 following with 30 zeros, right? So we call the S here as go, right? And the current here is the current end result for the current numbers we have chosen, right? And this array here is the current chosen numbers, right? And we are going to iterate all the candidates. And if a candidate can pass this condition means that the specific digit for the um, current candidate is 1, right? So if it pass the condition checking, we can um, we can do the AND operation to the current end result and the chosen number. And also we are going to push the chosen number into the array, right? And in the end, we are going to check if current end result equals to our target S. And if they are equal to each other, we can output the chosen numbers and end the program. I guess that's it. I hope that helps. See you next time.